Hello everyone! In this video I will tell you something about linear inequalities. First of all, I will explain what they are. That will be in terms of their graphs and in terms of their formulas. After that, I will explain how to solve linear inequalities, and I'll end with a step-by-step list on how to solve those. So first of all, what are linear inequalities? Let's take the same graphs as we used in the previous video. In the previous video, we were looking at the intersection. Where are the two values equal? With an inequality, we are not looking at where they are equal, but for instance, where one of them is higher than the other. Let's say this is graph A and this is graph B. We may be looking at where is graph A higher than graph B. If we have the graph and it's easy to read off, then we can already see that this is the case when x is larger than 4, but we may not always be able to see that. So let's have a look at our formulas. What does it mean for our formulas to find the inequality? Well, in the previous video we saw we could make an equation out of this to find the intersection. At the intersection, 2x minus 3 equals x plus 1. But now we're looking at a point where formula A, which is 2x minus 3, is higher than x plus 1. So instead of an equal sign, we write down greater than. So 2x minus 3 is greater than x plus 1. For the pizza example in the first video in this series, that means that once we can write the formulas for pizza place A and pizza place B in a more manageable form, we can also write them as an inequality to find out when one is cheaper than the other. So how do we solve those linear inequalities? Well, actually the first step is to make it an equality again. We will first look at the point where the graphs intersect, and after that we will look at where is one higher than the other. So as we saw in the previous video, we can use the balance method to easily solve this one. X minus 3 equals 1, x equals 4. What we're then going to do to actually solve the inequality is we're going to make a number line. We have found out that at 4, the two formulas are equal. Now what we're going to do is we're going to check what happens before that equality point and after that equality point. You can pick any number you want. I prefer to use 0 as one of them and some other easy number to calculate with, so let's say 10. For linear inequalities, it is technically enough to only check one of those. The other one works as a check to see if you made any mistakes. But as we go on to more difficult formulas later on, it will actually become important to check both of them, because the inequality may hold on both sides or on none of the sides. So we're going to check those 2 points. We're first going to fill in x is 0. If we fill that into our formula, if we fill that into our inequality, then the terms with x disappear, so we get minus 3 is larger than 1. Now I hope we all agree that that is not true. Then we also look at x equals 10. So we fill that into our inequality. 2 times 10 minus 3 is greater than 10 plus 1, or 17 is greater than 11. And I think we can agree that that is true. So apparently, at 4 it is equal, and higher than that, our inequality is true. So our inequality holds for any x greater than 4. That is the final answer to our inequality. So to summarize, let's write down the steps to solving a linear inequality. The first step, if you don't have it yet, write down the inequality that belongs to the situation that you have been provided with. If you have only graphs, if you have only a story, write down the inequality you need. The next step, the first real step to solving, is to write down the corresponding equation, the corresponding equality. Then, obviously, you solve this equality. After that, you check the inequality at a point above and below the intersection, so with the number line. Check where it is true and where it is not true. And from that, you make a conclusion, whether it's above or below the intersection point. These are all the steps you have to take to solve a linear inequality. Good luck!